Good morning, this is Mr. Keaton. I'm here to talk about the Hinge theorem and indirect reasoning today. This is section 5.6 in your book. I'd encourage you to go to page 355 here. 355 and see what the book has to say about the Hinge theorem, and I will go ahead and summarize it real briefly here. The Hinge theorem is like a gate. If two sides are set, the more the gate is open, the bigger the angle, means the bigger the opposite side. The smaller the angle, included angle, the smaller the opposite side. And that's simply the Hinge theorem in its entirety. There's the converse of the Hinge theorem, which says the smaller the opposite side, the smaller the angle. The larger the opposite side, the larger the angle. And that's the converse of the Hinge theorem. So over here we have two sides that are congruent. Two sides have to be congruent. There's the first side and the second side is congruent. And then they have an angle between them. That included angle tells you something about the length of the opposite side, whether it's larger. So we could say WX is going to be larger than ST because it's opposite the included angle. The larger the included angle, the larger the opposite side. Down here in the bottom problem with ABC and DEF, we see the same thing. We have two sides that are congruent and an included angle. Opposite sides, this is the converse of the Hinge theorem. Opposite sides are different, therefore the angles will be different. The larger the angle, the larger the included angle. So this is the larger angle. And over here we have a smaller side opposite the included angle, thus a smaller included angle. And we have measure of angle C is going to be greater than measure of angle F. Let's look at another problem. Going to the next problem here. Given that BC is congruent to DC, so BC is congruent to DC, how does angle ACB compare to angle ACD? Well, they have by the reflexive property, they have a share a side, so they each have two pairs, therefore we have included angles, and those happen to be angles they're asking us to compare. But if we look over here, the opposite side by the converse of the Hinge theorem are different. Therefore, those included angles will not be congruent. And we can say angle ACB is going to be greater than angle ACD by the converse of the Hinge theorem. This next problem is about runners. One is heading north 1.5 miles, the other is heading south 1.5 miles. And after they go 1.5 miles, they both turn. One turns 100 degrees to the right, which leaves an included angle of 80 degrees. The other turns 130 degrees to the right, which leaves an included angle of 50 degrees. And then they both run their 2.54 miles out. And the question is, which one of these runners runs farthest? Well, because the included angle, they both have congruent sides, two pairs of congruent sides, we can say something about opposite sides. This one, runner 2, must run less than runner 1 because his included angle is smaller, thus the side here is going to be smaller than this side here is going to be larger. So runner 2 must run less than runner 1. So to finish up, I'd like you to, we're going to have a second video here on indirect proofs, but I'd like you to go ahead and solve question 1 here on the left and go ahead and put that in for question 1 on the video, and then we'll move on to the more important part of this video tour is on indirect proofs. So pause here and move on.